If you saw my last video on the law of sines, you may have asked yourself, is there also a law of cosines? Well, the answer is yes. Suppose I have a triangle and I'm given 3 side lengths, in this case 4, 5, and 6, and I want to know what are the interior angles. You may be thinking, well, I could just use the law of sines to find that. But what's the problem there? In order to use the law of sines, I need to know at least one other angle. As of now, I know 0. That is where the law of cosines comes in to help us out. Given a generic triangle with angles A, B, C and side lengths A, B, C, notice the capital letters denote an angle, the lowercase letters denote a side length, and each one is opposite. A opposite A, C opposite C, B opposite B. Given that notation, the law of cosines states that c squared is equal to a squared plus b squared minus 2ab cosine c. In this arrangement, we could either be solving for side length c on the left-hand side of the equal sign, or angle c. A quick check to make sure you've written this down correctly is that your angle inside the cosine matches the letter on the left-hand side, c equal to c. Now c corresponds to this angle in our specific example. So let's plug in the numbers and see what pops out. So c corresponds to 4 squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 cosine c. I plugged in all the numbers, leaving one unknown, c. Now let me expand this out and clean up a bit. So following these steps, I come to negative 45 is equal to negative 60 times the cosine of c. I divide both sides by negative 60. So this goes away. Negative over negative cancels, and I'm left with 45 over 60 is equal to cosine of c. Well, 45 over 60 can be reduced to 3 over 4 is equal to cosine c. I'm solving for c. How do I do that? I'll take the inverse cosine of both sides. So that inverse cosine of 3/4 is equal to c. I'll plug that into my calculator, and I get c is equal to 41.41 degrees. Now make sure when you're entering this in your calculator, you're careful of a few things. First, that your mode is set to degrees and not radians. Secondly, that you're entering the keystrokes in the correct order. And lastly, that you're using inverse cosine, not cosine. A quick note in case you forgot. The inverse cosine of the cosine of theta is equal to theta. Likewise, the cosine of the inverse cosine of theta is equal to theta. More generally, when we plug the inverse of any function into that function, it spits out x, such as the square root of x squared is equal to x, and the square root of x squared is also equal to x. Now there might be some caveats with restrictions on the domain or range, but this demonstrates the point. Likewise, the natural log of e to the x is equal to x because a logarithm is the inverse function of an exponential. Similarly, e to the natural log of x is equal to x. If you're not familiar with this just yet, don't panic. The point I wanted to make is regarding the inverse trig functions. This also applies for sine and tangent and the others. A quick note on the law of cosines and its relationship to the Pythagorean theorem. You may have noticed that this portion of the equation looks awfully familiar. Well, if we plug in 90 degrees into cosine, cosine of 90 is 0, this term drops out and we are left with the familiar Pythagorean theorem. C squared equals a squared plus b squared, forming a right triangle. Now, if you didn't have access to an electronic calculator, trig tables, or other means to compute the exact value, you could notice some general trends. Namely, if c squared is greater than a squared plus b squared, that forms an obtuse triangle, meaning this angle is greater than 90 degrees. If c squared is less than a squared plus b squared, that'll form an acute triangle, meaning all the angles are less than 90 degrees. If you'd like further justification for that reasoning, consider the following. By rearranging the terms in my law of cosines and solving for cosine c, I get this. Now in the first case, if c squared is greater than a squared plus b squared, a bigger number minus a smaller number will be a positive. Notice the denominator has the negative 2ab, so it will always be negative. A positive divided by a negative is a negative, meaning cosine c is also negative, less than 0. Going back to our unit circle, remember that negative values of cosine fall in the second quadrant, beyond 90 degrees, making it an obtuse angle. We've already mentioned that if c squared is equal to a squared plus b squared, well, that'll make the numerator 0. 0 divided by anything is 0. Cosine of c is 0, meaning c is equal to 90 degrees, a right triangle. And lastly, if c squared is less than a squared plus b squared, a smaller number minus a bigger number is going to be negative. The denominator is always negative. Negative over negative is a positive, meaning cosine c is also positive, greater than 0. Positive values of cosine fall in the first quadrant, where angles are between 0 and 90 degrees, making them, by definition, acute angles. In our example, we labeled this angle as angle C. Now suppose I rotate my generic triangle such that I now have ABC, and this angle would now be B. Just be careful that the correct side length is opposite the angle, such as A opposite A, B opposite B, C opposite C. It's simple enough to rewrite the law of cosines in the form b squared equals a squared plus c squared minus 2ac cosine b. Again, just make sure capital B is in the cosine and lowercase b is on the left-hand side. It doesn't really matter which side I call A, B, and C, such that I'm consistent and keep track. You may have already gotten ahead of me and said, oh, well then we could also write that a squared is equal to b squared plus c squared minus 2bc cosine of a. And you would be correct. Just make sure that your capital A in the cosine and lowercase a on the left-hand side of the equal sign. B's and C's in the middle. Given that information, for your homework, I'd like you to find the other two angles. If we called this angle C, I want you to find angle A and angle B using the law of cosines. Then I want you to check your answer. First, check it using the law of sines. Perhaps the easier way to check it is to make sure that A plus B plus C is equal to 180 degrees, because every triangle in the plane has 180 degrees. Put your answers in the comments section below, along with any other questions you may have. Thank you for watching this video. I look forward to seeing you for another lesson.